we are going to be going through 3A, and if you look at 3A, it is a mammoth exercise. There are lots of questions. Finding the equation of a tangent, it's a very common exam style question, so very important skill to have. And you guys are lucky because you get this weekend to work on 3A, and we'll have some of Wednesday's lesson to work on it as well. We only have one lesson next week, whereas the other class, they only get one lesson to work on the whole exercise. So you guys are quite lucky. So today we're going to go over page 22 and 23, and then in our next lesson we'll start looking at some of the conjecture questions, okay? That's a really good indication of the difficulty of this unit. Alright, but we are going to start reasonably simply. We need to find the equation of a tangent and a normal. Now there are three processes that we can use. Three processes, and really you can use whichever one you want to use. Alright? And I'm going to show you all three. Okay? So firstly, when we think about what a tangent is, you've got the diagram of it. This is the equation of a parabola, of a quadratic, and a tangent is a line that is parallel to the curve. So you're finding the equation of this line. And we should think, if we want to find the equation of a line, we need to know the slope and that coordinate. And if we have those two pieces of information, then we have enough to find the equation of a line. So firstly, our first process that we're going to use, is just an intuitive process. We're finding the equation of a line. Okay, boys, just a bit quiet at the back there. Thank you. We're finding the equation of a line just using y equals mx plus c. Alright, so this is our function. Now, I've said to find the equation of a line, we need two things. We need the point of contact, okay, and the slope. Okay, let's consider the point of contact. We want to find the tangent when x is 4. So that means we need the y value. We've got the x value, we need the y value. Well, our function is the square root of x, and so our y value then is going to be the square root of 4. We want to know what is the y value when x is 4, and so we'll get 2. Alright, we don't consider negatives when we're performing an equation of tangent. So we've got x is 4, y is 2. We've got our point of contact. Okay? Next, we need to know the slope. We want to know the slope of the equation of this line. And so we're going, how do we find the slope? How about using calculus? We know if this is f of x, that f dash of x is the slope function. It tells us the slope for any value of x. So let's find f dash of x. F of x is x to the half, therefore f dash of x is half x to the minus half. Alright, let's write that as a fraction. That's 1 on 2 root x. Okay, and we want to know, that's the slope function. That'll tell you the slope for any value of x. We want to know what's the slope when x is 4. Alright, so we're finding f dash of 4. It's going to be 1 on 2 root 4. That's 1 on 2 times 2, which is 1 on 4. Okay, our slope is 1 on 4. And so we've got everything we need. We've got our point of contact and we've got our slope. And now what we're doing is we're going back to year 10 mathematics. We're saying we've got these two pieces of information. Let's combine them together to find the equation of the tangent. Alright? We're going to go y equals mx plus c. That's the equation of a line. A tangent is a line. We have a slope of 1 on 4. So we've got y equals a quarter of x plus c. Alright? And then we've got the point of contact. We've got when x is 4, y is 2. And we're going to input that into this line that we have here. 2 equals a quarter times 4 plus c. So we've got 2 equals 1 plus c. c is 1. Therefore, the equation of this tangent okay, now that is y-intercept form. And remember, when we have the equation of a line, there are multiple ways of presenting it. Here we have y-intercept form. The other way it can be presented is in general form. So I'm going to show you how we can move from y-intercept form to general form up here. If we have y is equal to x plus 1, we can multiply both sides by 4. We're going to have 4y equals x plus 4, and then we can move the x over, or move the y over. We can have 4y take x equals 4. Alright, that's the equation of the line in general form. It could also be represented as x take 4y equals minus 4, if you were to rearrange it the other way. Alright, both of those are different ways of representing it in general form. And remember, when we're talking about the equation of a line, they both tell us something. Here you can see the slope and the y-intercept, how steep it is, and the y-intercept. Here you can see the x-intercepts and the y-intercepts, okay? Because x-intercept occurs when y is 0. Y-intercept occurs when x is 0. You solve that, you get y is 1. Okay, so we can see both. Alright, next we're going to continue with the same equation here, but now we're asked to find the normal. The normal at x is 9. So if we have a tangent, so this is a tangent, a normal is a line that is perpendicular to the curve. Alright, so a line that's perpendicular, alright, if this line has slope a on b, then the perpendicular line has slope minus b on a. It's the negative reciprocal of a line. Okay, so we're going back to right at the start of year 11, maybe even a little bit of year 10. But we have a line, the perpendicular line is going to have this slope. Okay, by definition. Alright, so we want to find the normal at x is 9. So we need to find those things again. We need the point of contact, and we need the slope. Okay, so let's go and find these two things first. Okay, so for the point of contact, we're going to have x is 9. Y is the square root of x, so that means the y value is 3. The square root of 9 is 3. Now we have the same slope function, so I'm not even going to perform the derivative again. We're still talking about the same function. So our slope function is still 1 on 2 root x, and we want to know the slope when x is 9. Okay? That is the slope of the tangent. We are finding the equation of the normal. Alright, so because we're finding the equation of the normal, we're going to perform the negative reciprocal. Therefore, the normal has slope minus 6 on 1. We flip it. Okay? So then we've got all of the information that we need. Okay, in every process, we need to find these two pieces of information. Okay, and from there you could just go ahead now and do exactly what we did here, back to year 10 maths. Okay, there may be a faster way. You may find this procedure faster. We're going to find it in general form straight away. So I've written it at the top, right in the middle of our page 22 there. Okay. We should think about it like this. If we have slope of a on b, then ax take by equals c. And if we have slope of minus a on b, then ax plus by equals c. Alright, so let's look at our slope here, and let's figure out which of these forms are we going to use. It comes down to, is our slope positive or negative? Now we could write our slope as minus 6, but that's not going to help us here because we need our slope expressed as a fraction. If we just have a number, we can express it as a fraction by just putting it on top of 1. That's fine. Okay. So it's a fraction and it's negative. That means it's going to be this form. This is the one we're looking at. Alright? 6 corresponds with A, doesn't it? See how 6 and A, and 1 corresponds with B. Okay, so that means the statement that we are going to make here is 6x plus 1 lot of y equals c. Now, the 1 is, we don't need to write the 1, but I've put it there just to demonstrate the link from here to here. So what that becomes is 6x plus y equals c. Okay, and then in order to find c, All we have to do is sub in our point of contact. Okay? We've got 6 times 9 plus 3 equals C. 54 plus 3 is C. We've got C is 57. And so therefore, the equation of the normal is 6x plus y equals 57. Okay. So what have we shown? 2 processes. We always need the point of contact. We always need the slope. And then then you can use general form if you prefer, or you can use y-intercept form. All right? It's good to be competent with both, and particularly to understand what general form is and how we can manipulate it back to y-intercept form. Because I think this is the form that we're probably most familiar with. But yeah, be competent with both. Any questions about those 2 so far? Okay, let's power on. We're going to now sin x at x is pi on 3. Alright, so this time, let's use the 3rd procedure. I said there was 3. Alright, so we've used just an intuitive process, finding an equation of a line. We've used general form. Now we're going to use a formula. And some people like formulas, and the formulas are both listed there. Alright, tangent. The formula for a tangent is f dash of a times x take a plus f of a. Okay, let's describe what this means to you. This is the slope at x equals a. That stays as x. This is the x coordinate of the tangent. So we're talking about the tangent at x equals a. And this is the y coordinate at x is a. Okay, so we still need to find those things. We need what is, in this circumstance, okay, we're finding the tangent at x equals pi on 3. That's our behaviour. So, point of contact is going to be x is pi on 3, y is sine of pi on 3. Okay? And like I'll explain my reasoning around this, around the unit circle, okay? There's 4 possible values. It can be 0, half, root 3 on 2, and 1. There's 4 values it can take. Alright? And then if I'm looking here, because that's pi on 6, pi on 4, pi on 3, alright, so it's getting close there. And I know that that has a larger y value than it does an x value, so I know that's root 3 on 2. You can look at the unit circle. Alright, so that's what this one simplifies to. Pi on 3 and root 3 on 2. That's our point of contact. Next, we need the slope. So in order to find the slope, we need the derivative. The derivative of sine x is cos x. Okay, there's our derivative function. And so then, the slope when x is pi on 3 is going to be cos of pi on 3, which is half. Okay, so we've got the point of contact, we've got the slope. Okay, and if it helps, make a list. Point of contact, do a tick. Slope, do a tick. And now let's bring it together. And this time we're going to use the formula. Okay, so f dash of a, if this is the formula, okay, is y equals f dash of a times x take a. I might write it out here actually, so then we can just substitute stuff in underneath. X take a plus f of a. Alright, here's the slope. F dash of a. So it's going to be half. Here we're going to write x take the x value of the tangent, which is pi on 3. And then we have plus the y-intercept, the y-intercept, y coordinate, plus root 3 on 2. Okay, so slope, x take the value where we're finding the x-intercept, and then plus root 3 on 2. Okay, so now what we would do is expand this and collect like terms if we can. Alright, so what we're going to have is half x take pi on 6 plus root 3 on 2. And that's it, okay? Here's the slope. This thing here, this ugly thing here, is the y-intercept. Alright? And you could put it in your calculator to a couple of decimal places, but that's it in exact form. So it's the equation of a line that's tangent. Oh, were we supposed to do the normal?
Yeah.
That's okay, it's easy to fix. Let's do both. Okay, so here's the tangent. Below, let's do the normal. Okay, everything stays the same except the slope. Okay, everything stays the same except the slope. So in order to find the slope of the normal, you notice the formula is minus 1 on f dash of a. Alright, times x take a plus f of a. So this becomes minus 1 on top of half. And then it's times x take pi on 3 plus root 3 on 2. And 1 divided by half is 2. So it's minus 2 times x take pi on 3 plus root 3 on 2. Okay, and again we can expand. I won't because I don't have any room. Alright, any questions about that one? Cool, okay, next one is 2e to the x. So notice this is the difference really between year 11 and year 12, okay? In year 11, you're just mainly dealing with like quadratics, okay? Pretty simple stuff to differentiate, find the slope. Here we've got trig, we've got exponentials, we've got logarithms, so the complexity escalates. And here, we're not even given a real x value. We're just told x equals ln b. Like, what is that? Could be any number, really. So, here's our equation. Find the tangent, let's make sure, find the tangent at x equals ln b. Alright? So, we need to find firstly our point of contact. We've got x is ln b, and y is going to be 2e to the power of ln b. Alright, what does that simplify to? E to the ln of x equals x, so e to the ln of b equals b. Alright, so that 2 is just hanging out, e to the ln b is b. So we've got a point of contact. Let's do a slope, okay? If this is f of x, then f dash of x is going to be 2e to the x. It doesn't change, does it? That's the meme on the front. So then f dash of ln b will be sub ln b into this equation. We're going to get 2e to the ln b, which is again 2b. Okay, so got our point of contact, got our slope. Alright, they're the two things we need, aren't they? Point of contact and slope. Now we're ready to find the equation of this line. And let's go back. Oh, my favourite process is just y equals mx plus c. You do what you want. We need the equation of a line. Has a slope of 2b. So 2b is going to go where n is. Alright, and the point of contact, when x equals ln b, y equals 2b. Alright, and so here we're going to have c equals, all I'm doing, keeping that there, I'm going to subtract this. Alright, so I've got 2b, take 2b ln b. Alright. And hopefully you're looking at that and you're seeing, oh, we could move that up there. We could have ln b to the power of 2b, but this is fine. It's fine to leave it like that. Okay, we've got everything to state the tangent, albeit it's an ugly one. It is y equals 2b x plus, and this is our value of c. 2b, take 2b ln b. Okay. equation of the tangent at x equals ln b has a slope of 4. Find the value of b. Okay, so now we're told this tangent, all right, remember it's the equation of a line, has a slope of 4. Find b. Well, our slope is 2b. That's our value of n. So we have 2b equals 4, b equals 2. Okay? So the difference, this last one here, okay, a little bit nasty because there's no numbers, isn't it? It's just letters, but you can see the process is the same. Any questions about any of those? Okay, so it starts off just finding the equation of tangents, and then it gets a bit harder. You have a question? No. So yeah, see how we go, and try and use all of the processes. Okay, try and use all of them. Start with what you're comfortable with, though. Cool. Let's get into 3A.